Hi everyone. So this is Amarjit back again. So we had been discussing SVM, SVM classification model as well as K nearest neighbor algorithm and the naive Bayes algorithm for spam filtering. So this will be a demo for all the three algorithms. The programs that are being executed and the performance will be evaluated from these programs on the dataset. So I just want to give you a brief idea about the dataset we're using. So the dataset I've used is from uci.edu, and the number of instances used is in the database is 4601. The number of attributes has 58 attributes, and the last attribute is called the class label, which defines whether it is a spam or a ham. Then it has 48 continuous real attributes of type frequency word, and which is equal to the percentage of the words in the email from that match word. And then there are 6 continuous real words that match the type character frequency character, which is the percentage of characters in the email that match character. Then we have a few continuous integer and real attributes, following by the last one, that is the normal class attribute, which defines whether the email is a spam or a ham. So initially I'll take you to the code walkthrough. So starting off, the naive Bayes algorithm, I'll just give you an idea what is happening in the code. So this is the function that loads the database file, and then it splits the data set. I'm splitting the data set into as a ratio of 0.7 into training set and the testing set. And then we are calculating the standard deviation, then we are calculating the probability, then class probabilities, and then we later on are also calculating the accuracy. So if you can see, we are actually comparing the last column of the data set along with to the prediction we have achieved, and then calculating a percentage of all the instances as to how many were correct predictions. So I'll just give you an output. I'll give you a running version of the program. So let's see. Python naive Bayes. So as you can see, I've actually split the training set, the data into 3220 rows of training set and 1381 rows of test set. And the accuracy for this particular run is 81%, and the time you elapsed is 0.38 seconds. So it's actually very fast. I've never seen any other algorithm run this fast. So going ahead further, let us move on to KNN algorithm, that is K nearest neighbor. So we have the following functions which loads the data set from the CSV file, and then we calculate the Euclidean distance of all the neighbors from the test set. So which each instance of the test set, and then we are trying to fetch the neighbors, and then we are again using the same get accuracy function, which is again matching the last column of the data set with the predictions achieved, and gives us the accuracy. Let's go ahead and try and execute this. This is KNN. So generally KNN would take quite some time to complete the execution, because it tries to compare all the points and then come up with the nearest case data sets. So in meanwhile, let's just go ahead and see the multi-class SVM code. So in this multi-class SVM, or as we call it, SVM algorithm, what we're doing here is that we are taking two separate training data file and a testing data file, and both are equally split, as in it has been split, and the spam based data set has been split and stored into these two files. And we have the SVC SVM SVC library available in sklearn with Python, which actually helps us do the execution very easily and without having to write a huge code. So it gives a library which you can use directly. So, oh, great. So our application has our an algorithm has executed, and it's actually taken 74 seconds for this k nearest algorithm. The training set and the test set, as you can see, are divided in 3184 and 1486 instances, and the time elapsed here is 70 seconds, whereas this accuracy is 74%. And if you compare this to the naive-Bayes algorithm, this is very, very slow compared to naive-Bayes algorithm, where naive-Bayes was taking around maybe 300 385 milliseconds. As you can see just right above, we ran the algorithm. So I believe this algorithm is comparatively slower than naive-Bayes algorithm. I've actually previously tested a couple of data sets. Couple of times I've run the algorithm, and I've seen that even with the value of k, since k nearest neighbor uses the parameter system parameter or the user parameter k, even with the increase in value of k, there is not a lot of difference in terms of accuracy, even though I did see there was increase in time elapsed. So as of now, I feel it looks like, based on the experiments, that naive-Bayes algorithm is the faster filtering algorithm. So the next step, let's go ahead and execute the multi-class SVM algorithm. Oops. Oh, oh, it seems the sklearn library is not installed. Actually, I've just moved to a different system, so I'm not really sure why the library is not there. Uh, let me see if I have the results for this. Well, thankfully, I do have the results for this algorithm. So maybe there's some issue technically. I'm not able to. Probably the library is missing, but I do have the results for SVM, and let us just check that out. So this result is the output of the algorithm, and if we look at the so this is the actual output of the algorithm. These two entities here, the first column is actually the probability whether an email is a spam uh, is a ham or not, and the second one is the probability whether email is a spam or not. So based on these values, the probabilities is based on this spam an email is classified into a ham or a spam. So so suppose here we have 0.89 as the probability of probability of email being a ham, whereas 0.10 is the probability of being a spam. So based on this, the email is classified as a spam or a ham. And later it is also I've also compared it with the results here, and I have found out the accuracy um, to be, I'll just give you the number. I just had that noted down. So the SVM accuracy that came out to be was 79.93. I'm really afraid that I'm not able to run this program here because of this library. But the code which is there for a multi-class svm.python is a completely working code. There's no doubt about that. So I will close on with a conclusion that out of all the three algorithms that we have discussed so far, I felt that the naive-Bayes algorithm is one of the fastest algorithm in terms of classifying an email, whereas SVM is a little is way better than K nearest algorithm as well, and but K nearest algorithm is the slowest one and has the maximum running time. So that way. I would put it as a in the decreasing order of performance in terms of running time would be for the naive-Bayes being the best, then SVM, and followed by KNN being the worst. So this is all about this is all there from my end regarding this spam filter algorithms. Thank you for having the patience with me, and it was great to get this opportunity to speak on this particular topic. So thank you so much. You have a good day. Bye.